competition announcement, the second group of the hackathon. This one, I would like to invite my good friend coming and dialing in all the way over from Spain, Jesus. Jesus Hormick is the Chief of Cloud and AI Officer for Screening Eagle Technologies. Here he is. Thank you very much on screen. Jesus, good to see you. And you have the honor to present the next batch of the second challenge that we have in our hackathon. With that, I would like to give it over to you.
Thank you very much, Thomas. Hello, everybody. Welcome back to the grand finale of the hackathon. The availability and quality of data plays a pivotal role in the development and success of AI applications, as you know. And data is the lifeblood of AI. It fuels machine learning algorithms, enabling them to recognize patterns, make predictions, and solve complex problems. However, the reality is that obtaining and curating large, diverse, and high-quality datasets can be a significant challenge. And this is where synthetic data comes into play. Synthetic data refers to artificially generated data that mimics real-world data that is created by mathematical models and algorithms rather than being collected from the real world. It is a groundbreaking solution that has the potential to transform the landscape of AI development. Some of the key points to consider in the real world of synthetic data are the data scarcity and privacy concerns, as Rashmi from the Capital mentioned before, or the diverse and controlled data generation. Synthetic data enables the creation of diverse datasets, cover the wide range of scenarios and edge cases that you cannot cover with real datasets. Also, data augmentation, which is a common in machine learning, that augmenting the data to increase the size and diversity artificially. Synthetic data can be used in this case alongside real data to further enhance and train the training process, making AI models more robust and accurate. Also, a very important point raised by Radhika and Eva Maria before is reducing bias. I mean, bias is a big problem in AI, and it's a huge and significant concern. So synthetic data allows developers to create balanced data sets, reducing all these biases that may be present in the real world data, actually the one that's present freely on the internet. Also, there's applications in various fields. Like synthetic data is not just limited to specific industries. One can create data for healthcare, autonomous vehicles, finance, retail, and countless other sectors. As we look into the future of artificial intelligence, synthetic data holds some tremendous promise. It is a powerful tool that can help us overcome data limitations, enhance the model performance, and build a more ethical and equitable AI system. In the upcoming sessions, you will have the opportunity to discover how synthetic data is being applied by some of our participants. Let's move on straight away onto the second competition, which revolves around this topic. Today, we have the privilege of hosting the top 3 finalists. And first in our list, let's extend a warm welcome to Shirish Singh team. Their project promotes an innovation in the sector with limited real data sets, encouraging the utilization of synthetic data. Overcoming the primary challenge of synthetic data quality, Shirish Singh's team offers a solution that involves comparing synthetic data with real data through statistical tests, ensuring that the data is fit for use. This approach increases the trust in synthetic data and consequently enhances its adoption. This team is formed by Shirish Singh, Aryan Aragwal, Vanessa Dietze, Ragwal Kaushal. Please, let's have Shirish Singh on stage, please.
Hello, everyone. Our project is in the synthetic data applications category of the contest. The project is about driving the adoption of synthetic data in the industries and the scenarios where real data is very limited or severely restricted because of the regulatory or privacy concerns. If you do a Google search to find what are the challenges in the synthetic data adoption, the topmost challenge comes as a lack of trust or lack of accuracy in the synthetic data. Our solution compares synthetic data with real data using a series of statistical tests and inspects whether the data is fit to use, whether it accurately captures the structure and the patterns of the real data. This will increase the trust in the synthetic data and in turn will increase the synthetic data adoption. This diagram is a representation of a workflow wherein on the left hand side the data scientist can start with limited set of the real data. They can use the existing data generation tools like mostly AI or Gradle or Hazy, and after that they can integrate our solution to identify fitness of use and the data validation. They will get the RX report. The reason we are calling this RX report is that it is very similar to a health check report, wherein any of your health parameter which is out of the specified range, doctors looks at it and then give you a medication or there is an intervention required. In the similar fashion, we will also run each and every variable which is synthetically generated through the series of statistical tests and will give a report to the users saying that whether it passes a particular test or not, and they can choose and decide how do they can fine-tune it for the purpose of their further model building. These are some of the screenshots of the RX report. What we did as a part of this activity is that we looked at Titanic dataset from Kaggle. The challenge in Kaggle was to find or predict whether the particular passenger survived or not. There are some 900 passengers on the list. We run it through two different tools, mostly AI and Gradle, and ask these tools to give us 10x of the data. So these tools give the synthetic data and then we run it through the series of tests. Since this was a tabular data, we looked at a certain series of the data. Our solution covers two types of the data. One is a tabular data and another one is a matrix data, like the image data sets. So we have different sets of statistical tests depending on the type of the data. So users will get this pass-fail kind of a report. This is a very good example wherein most of the parameters or variables are passing the tests. Only one is there. That too, it's not very difficult one to kind of fix and fine-tune. On the right hand side, you can also see in a pictorial form that how the distribution looks like of synthetic data versus the real data set. We recently released this library just about 2 days back. We already have 400 plus downloads. It's very encouraging sign for us. So here also all the participants, viewers, I would request that you try out this library. It is called Synthetic RX. Just do pip install Synthetic RX and try it out. This is our team. We are distributed across globe. Vanessa is based out of Germany. Prajwal and Aryan are studying in US. And I'm Shirish, based out of India. Our mentor Philip is based out of Brazil. A little about the inspiration also, that from where the inspiration came. I volunteer for Safe Soil. This movement is all about protecting organic content in the soil. Soil is soil because of the microbial life and the organic content. If you take these two elements away from the soil, it will just become sand and you won't grow anything. So when I wanted to baseline the organic content across India, I hit the roadblock because the resolution of the satellite imagery required to do the baselining of organic content is only available with very select government agencies. So I started looking at, is there an option that we can use the synthetic data? And then looking at it, we hit the hurdle of lack of accuracy. We said that why don't we work on solving this problem? So with that, I would thank the organizers as well as judges to give us an opportunity to present our project. Thank you.
And we have today with us JellySpace, their AI and DLT-based supply chain toolset for the space
are you ready to
and defense industries aims to lower their AI DLT-based supply chain toolset for the space and defense industries aims to lower the barriers of entry startups, small and medium enterprises, and mid-sized companies looking to the venture of the aerospace industries. The team is composed by the following members: Ali Musab, Maximiliano Alarcón, Krishna Suttar, Aniket Sharma, Shreya Srektandam. The spotlight is yours. Please join us.
Hello, everybody. Can you hear me?
Yes.
And can you see the screen?
No.
Just a moment. The system doesn't allow me to share the sound from my computer, but you can still hear me, right?
Yes, we can hear you.
Okay, so then there'll be a problem with the video because I have a video in the slides. I would not be able to. You will not be able to listen to the sound, I think. So just a moment. Let me check this computer audio. So, okay, anyway, just let me start without wasting time. So,
yes, thank you very much.
Please, Ali, just start the video. Seems there are some issues in the back, and we can hear you fine. And if you can share, then please just share and we go.
Can you see the screen? Can you?
Yes.
Yes, we do see the screen.
Now, can you see it?
Yes.
Okay, yeah. So, sorry about that. So yeah, hello everybody. My name is Ali Musab. We are Team JellySpace, and we are super excited and thrilled to be in the finals. I feel both elated and humbled to be before you as a finalist in this esteemed AI competition. The journey has been enlightening and challenging and incredibly rewarding for us. And as a team, we are brimming with gratitude for everyone who has been the driving force behind this competition. Our vision, we are JellySpace, empowering the space industry and the defense industrial base with AI and blockchain-based supply chain tools, fundamentally removing the entry barriers in a total serviceable and addressable market greater than $180 billion. Benefit for humanity, JellySpace is interested in strengthening supply chains that contribute to solutions for energy problems and climate change. The platform as a service can also aid in reconstructing supply chains post-crisis. This includes collaboration with entities like NATO's Crisis Management and Disaster Response Center of Excellence, the Red Cross, Federal Emergency Management Agency, and NGOs during various crisis scenarios, from wars such as the ongoing Ukrainian-Russian conflict and environmental disasters to political upheavals and energy supply disruptions. Why our grand claims are possible now. What was promised in 2G was not completely delivered in 3G, and the promise of 3G was partially delivered in LTE or 4G. But from 5G onwards, the major promises have been kept with respect to the high-speed data rates and low latency, providing high-quality communication with respect to audio and video, helping companies develop a ground framework for smart cities, industrial automation, self-driving cars, and mission-critical applications. We intend to claim our success on what 6G promises and plans to deliver. That is synergy between communications, sensing, positioning through AI algorithms, and compute. The major pain points that aerospace supply chains would face will be the threats against cybersecurity, data privacy, and AI regulations. We as JellySpace intends to deliver machine learning models-based platform as a service, fenced with enhanced cybersecurity and blockchain-based backend. 6G is no longer a myth, and it already exists in space. Nokia has already demonstrated its 6G-based lunar network at the Mobile World Congress 2023. Such networks can help space and non-space industries leaps and bounds. Major space agencies across the world are ready to deliver 6G communications. Let's watch what European Space Agency has to say. Yeah, we are aiming for a major paradigm shifting AI platform for the space and aerospace industry that can utilize both real-time and static data. We intend to leverage both synthetic and real data-based machine learning models to tackle multiple supply chain use cases and scenarios. One of the dominant commercial use cases for our tool set are the maritime supply chains and in-space logistics. AI models that consume satellite data can help optimize maritime as well as in-space logistics. Strengthening space solar power supply chains can provide alternative solutions with renewable energy sources. There's an opportunity to incentivize and monetize the space sports and launch vehicle supply chains. Also an opportunity to disaggregate the legacy structures or dominant powers in this domain to provide equal contributing opportunity for small, medium enterprises and startups with AI and blockchain-based ecosystem and framework. The practical implementation, disintermediate the supply chains from middlemen by using AI and blockchain technologies, provide zero trust cyber secure platform against intellectual property theft, help companies navigate the compliance and regulatory issues through shared, immutable, and transparent blockchain distributed ledger, enable new entrants to enter this conservative market and create competition, provide quality at lower prices, leverage quantum computing and the compute in-memory architectures for AI algorithms, and eventually make space and aerospace technologies accessible to all. We would like to thank the WowDAO team, the mentors and judges for providing us with this invaluable platform to learn, grow, and showcase our passion for artificial intelligence. Thank you very much for listening.
Thank you, Ali. Thank you. Nice presentation. Continuing our exploration of the synthetic data applications category, we are delighted to introduce the Make It AI team. Your presence here is really appreciated, and we eagerly looking forward to learning about your innovative project. Please join up on stage, Israel Orede.
Hi everyone, this is Mickey.ai and I'm presenting today on my solution for synthetic data. I start with a rare age-related disease dataset from Cargo. This dataset consists of positive samples, negative samples where the person has disease and where the person doesn't have disease. And datasets like this often come with issues like label noise, wrongfully labeled data, where positive samples are labeled as negative samples by error, and vice versa. We saw measurement errors in processing, collection, storage, deliberate data corruption, and uninformative features. All of this affects the real signals in the data. And just like noisy images, this noise prevents the model from seeing the real signals in the data and giving you good performances on your downstream tasks like regression or classification. So John is a medical researcher and John is trying to work with this data set, and the data privacy concerns, you cannot just download the data set and use it. So you need to generate synthetic data, and that set data has to match the distribution of the real data. And this data set is highly imbalanced, so it's kind of like a problem for him, because positive sample and negative sample ratio is about 6:1. And then the quality of the data set is also an issue because of this, noise and all of these collection and measurement errors I've listed before. And my model architecture, I start with a discriminator, where this discriminator is trained to distinguish between fake generated samples and the real data sample. So it knows whether a generated batch of samples is fake or real. And my model architecture, I start with a Gaussian for each feature. So we repeatedly draw samples from that Gaussian for each feature. We populate for all of the features, then we generate a batch. Then we pass this batch to a base model like a logistic regression model, and this model basically is trained on the generated batch, and then it tries to predict whether this particular sample is, is a disease sample or not. So we train on generated batch, and then we ask the model, to predict on the real data sets whether this sample is positive or negative. And then because we have the ground truth, we compare with that, and we try to generate data that helps the model distinguish better, between positive and negative samples. So generator is trying to find the best data representation and, a data set that actually, gives the model a full picture of the real signal and data. And discriminator, remember, is able to test whether this generated data looks like the real data in terms of distribution. And so it penalizes the generator for generating samples that don't look like the real, distribution. And then the discriminator tells generator that, okay, this generated batch you gave me, to give to this base model is not doing very well in helping the model classify between real and positive samples. The generator has to go back and generate better batches of data. And then when I worked this across different test sets, I discovered that the performances for the synthetic and real data were actually in tandem. And when I worked on another data set, I discovered that the performance on the synthetic data was actually higher than the real data. And then I discovered something interesting when I was experimenting with this data on the previous slide. I discovered that as you penalize the model for generating samples that are, kind of quote unquote far from the real data distribution, the performance of your logistic regression model on this your task of classification drops to when you were just training on the real data. So we are saying, okay, no, generate samples that look exactly like real data. So the model is going to generate such samples, but you will lose the ability of the model to generate samples that really show us the signals and data, samples that can help us classify. If you penalize the model too much for generating samples that are too far from the real data distribution, it starts generating samples that look like a copy of what you had before, and then you just have a performance like you would have had if you had trained on real data, which is kind of intuitive. And we have, things like custom laws and metrics that you can define. This can work. This architecture works with classification and regression. You can define your generator and discriminator to match your task and your data, whether it's image, audio, tabular. You can also work faster with maximum memory constraints as a parameter, reducing your epoch and batch size, and using your feature importance and PCA or TSNE to reduce the amount of data you feed to the model, which can help you to do experiments faster. And then we want to create an API service, uploaded models and metrics and loss functions for various field and research areas like medicine and healthcare and finance. So you don't have to do all of this by yourself. And then we also want to make it a platform for knowledge sharing and experimentation. Finally, I would say that synthetic data is good, but it is more meaningful when you can get better results on your downstream task. So synthetic data is good, but meaningfulness in downstream task is more important. Thank you.